6. And we're recovering right now. So let's see. Another reason, another point towards me wanting to switch to Linux for debugging. Yeah, sorry about that. My computer is crashing sometimes when I'm debugging. It doesn't happen any other time except for when I'm in Visual Studio, in the debugger, debugging something. Which I pretty much rely on for all my work. So it's very frustrating. Let's see if I lost any work. Or if it's still in my local working directory. It looks all good. Maybe I should check it in though. Not tempt fate further. Check it in so I don't lose my work. Okay, so this is all about... We just added add a graceful indicator added to connection broken delegates. Yeah, I should have like a, I don't know, some kind of overlay when like everything blows up. Okay, what do we change here? Same thing, right? So I can just paste from the clipboard. WebSockets. Commit that. Push that. Okay, Visual Studio, are you ready to go? It actually looks like it reset my preferences and stuff because the output window is not locked. And I'm not seeing my other windows, so let's see. I want breakpoints, and I want... Where are my other windows? Error list. This got somehow reset. That's probably good enough for now. Let's not debug though. Let's just run the test from the command line, see what we can do. So, system abstractions test debug, system abstractions, detest filter equals, it was receive, close, right? Right, so it's not getting that final disconnection. That one right there, right? 954. And it is waiting a second, so it's not getting that broken delegate call. So it might be because we're doing that. Okay. Let's look and see. That should cause it... Hey, how was it going? The sump? 5.5? Pretty good, except for my computer is crashing. Something to do with the Microsoft debugger, so I'm trying to debug an issue right now just by looking at the code. Which makes me feel a little crippled. I guess what we can do is add extra debugging. Let's just do that, so that we don't have to use the debugger. We'll put something in here saying processor breaking due to resend error. We'll make that one line for ease of reading for now. And then this other break. I'm just expecting right now it's breaking out in one of these places. And I just want to narrow it down. And this one, oh, dir instead of do. This is due to send. Breaking due to send. What is this? Send returning 0. Basically, that I don't think that should ever happen, but maybe it is. Who knows? And this continues until it's told to stop. So let's have to print that too. Processor returning due to being told to stop. And then in our test, I think I need to enable the diagnostic stuff. Okay, we're not actually printing anything out. Okay, where did I had tests that did that though, so let's look for them. Did you mean Visual Studio's built-in debugger? Yeah, it's for some reason it's always when I'm in the debugger, I'll step or I'll tell it to continue, and all of a sudden I'll get a blue screen of death. And I've tried everything except reinstalling Windows, and I can't find any hardware issue. And a friend of mine told me that he thinks that there is a bug in the debugger. I don't know if I believe it. I think it's more likely I need to reinstall Windows or I have a hardware issue. But it's only in Visual Studio's debugger that I can get it to crash. Okay, so yeah, I'm looking for Diagnostics. Okay, one of these I have it. Yeah, the whole piece, it's really disruptive because my stream goes down and everything, and about half the time I discover later that system files have been corrupted. But it never crashes anywhere else. I can run it for days just playing games and doing anything but debugging and have no problems at all. Let's see. You know, maybe it has something to do with OBS. Who knows? I should try like running OBS when I'm just doing non-debugging for the rest of the day and see if it ever crashes anywhere else. System abstractions test. I'm trying to remember where I might have done diagnostic printing. What I would have called it, right, would be subscribe. Now I put my find way over on the other monitor. Everything got all corrupted, I think, in Visual Studio. That last reboot. Okay. Subscribe to Diagnostics. I'll look for this in a... oh, here we go. Oh, that's not the right one. It's gonna be in one of my tests. Ah, here we go. I want one of these. I want that to go in the framework, or the fixture for these tests. Where is the fixture? Here it is. Oh, I guess that means I have to have the client... how am I going to do this? If every test has one of these, I can just build it in. Let's be optimistic and say that that's the case. So we need these two. There, and the unit under test. Okay, then we're going to find that guy, client, right? Collapse that. I'm going to collapse the ones that I have updated. So that goes there. This is client. Wait a minute. Okay, that was just a transient problem. Okay, so my little formatting thing is in my string extensions. Okay, and then let's see. Where is the connection here? Here it is. Collapse that guy. Client. Where are you, client? Here you are. Okay, getting there. And there we go. Client. All right, so this is gonna put it into that, but let's also print it. I probably have that somewhere else too. Let's see. Okay, where else might it be? Here? No. Nope. I could have sworn I had like a way to also print them to the console. I guess if I look for printf, I'll find it. I don't call printf very often. I need printf with matching whole word. Okay, it's, yeah. I did do it there. I guess I didn't do it anywhere. I thought I did. Hey there, not Zane. Have you tried using Gdb To Test? As a matter of fact, that's what I'm thinking of doing because of this annoying crash. I am considering exploring using VS Code to integrate with the build system and the debugger on Linux. If I get those two things done and working for me, I might seriously consider switching to that instead of using Visual Studio, at least until I figure out what's going on with my computer. So yeah, I think I would use VS Code. I just need to learn how to integrate it with the build and the debugger. I think it's just a matter of me trying it out and getting some experience in that, which is why I think I put it in here as a future stream to do. Okay. Let's go back to network connection tests. I guess what we'll do is we'll just, in addition... Oh, no, I'll just do it right. To do it right, I think I will have a flag, bool, print diagnostic messages equals false. Visual Studio does have C-Lang support. Actually, that's another... Or is it Clang? That's another thing I could try, is switching to Clang, which will run a different debugger, right? Let me put that on the list. Explore using Visual Studio for debugging, but use Clang instead of Microsoft's tools for building debugging. So definitely another option I could try. If this flag is set, we will print all received diagnostic messages in addition to storing them. So what I'll do is in the test I care about down here right now, I will set it to true. Let's see all diagnostic messages as they happen. Because we're not debugging, we are running it on the command line. Okay, something's not right here. It's not a variable. You say so? Looks like a variable to me. Oh, I suppose it's because it needs to be a value. Okay, it's the capture being funny. So what I'll do is I'll just say this. All right. I'm not getting my printf. I did something. I didn't do something correct. What's going on? Oh, I added that flag, but I never used it. That's what happened. So if we print, then we're going to just also print this out with just normal printf. And I probably need a semicolon there, don't I? And then we'll probably want standard element. O comes after n. Include standard IO is a polite thing to do when we're calling printf. All right. Ooh, it's messy because I don't have a new line. Okay, we got a connection closed. The processor was running, but it never sent the break. Let's see, let's instrument that some more. Can that work? Where is it? This one. Let's just print whenever we, well, yeah, let's do it here. It'll be called in our test right here. Printf client connection broken. Graceful. Graceful. Yes or no? Client connection broken, graceful, no. Yes, and then no. Okay, it happened, but after we waited a second for it to happen, so something's still not right. Should have happened right here. Oh no, not right there, right here. That should have caused the client connection to receive something. Maybe the problem is we're skipping over it. Actually, I think that's what it is. What do I expect here? It's okay. Okay, I'm not understanding this. So it really doesn't matter if we close that or not, does it? Because the server is just sending us stuff and it's just going to close its end when it's done. Yeah, which it does. Actually, there's one way to test that. So it'll be an additional receive. Verify the server closes its end after sending the last message. So the verification is you just do an extra receive call and you assert, or we can just do expect actually. Expect, let's keep that bytes received and we'll just expect bytes received equals exactly 0. If not, let's print it out. Bytes to receive, okay, I guess we need that. Let's just let it receive as much as it wants to receive. It should return right away. Okay. Actually, this is not exactly true. This doesn't trigger the server closing. The server closes all by itself. We just need to do all anyway. Is that done automatically? Yeah, so we have... No, hold on. Yeah, so we have this thing to automatically close. So we don't have to actually do it. It doesn't matter. Verify... Well, the unit under test is the client. receives the indication. That the connection is broken. Yeah, sure. So yeah, it's when it reaches the end, this thing. So this close immediately should have called us, but it's not. So let me see what's going on by putting another diagnostic in here. Okay, processor closing and done sending. Processor closing connection immediately. And let's put another one inside of close immediately. Just because I'm, I guess, obsessive compulsive about wanting to see more data. Writing a web server in C++. Yep. Just use Node. Well, the whole point of my stream really is to have fun and teach others and what else? Go through the different low-level protocols, which I kind of did in the first 20 streams or so. So it's sort of a contrived objective, but I have fun doing this stuff. One thing I like to do in C++ is to try to make things cross-platform. So I don't know if you've seen it, but there's a link below to my notebook. And in my high-level diagram, I'm kind of happy in that, except for the tests, all of the stuff that's different between Windows, Mac, and Linux is all in this system abstractions library. And the rest of my web server is pretty much cross-platform. So I really enjoy doing that, and that's maybe one reason I'm doing it from scratch. Making fun of the mass majority, yeah. So yeah, that's what I'm doing. I'm working on a design flaw in my network connection class, which abstracts sockets, by the way, if that's not obvious. I wasn't handling graceful closes until today, and right now I'm not quite getting the behavior I expect to see in my unit test, which is explained here. Low-level stuff is awesome. Enjoy it much more than high-level programming. It's got its pros and cons, I guess, yeah. Some people like it, some people hate it. That's cool. Alright, so I instrumented more stuff. I'm doing a lot of extra diagnostics today because I'm having issues with my computer crashing when I run the debugger. So I'm trying to do it all outside the debugger. Okay, it's getting stuck now. Huh. I bet it's getting stuck in that receive. Which means it's actually not closing, is it? Yeah. Let's print out something else here. Message received. Waiting for server to close. Or waiting for the server to close. Or no, it's waiting for the client. It's the client that we're testing. It's supposed to close, but it's probably the bug probably is that it's not. Client closed. Alright. Yeah, so the client isn't closing its end. What's it doing? Let's print out more stuff from the processor thread here, which is supposed to be closing, but it's not. Assuming that you wrote all this down, all of this from scratch, trying to stick with just C++ language and standard library. So the system abstractions does use stuff like WinSock and BSD sockets on POSIX. So, but I kind of consider that part of the standard set of libraries. But yeah, the rest of this stuff is, yeah, not depending on anything but that. I'm just reading chat. So yeah, the low-level components will interact with the OS, yeah. So yeah, but later though, I'm gonna get to more complicated things. So where did I have that on my roadmap? To support the transport layer security. Is that what it stands for? I have that in my names, don't I? I don't. I'm horrible. I need to update that. Transport layer security. Just to handle that, I'm going to need to handle encryption, right? And I'm not really prepared to do that. So what I've been researching lately is to find what libraries are out there and how to use them. So I'll be deviating from my writing everything from scratch thing there. I've been looking into, these are like all the alternatives I've been considering, and right now I'm leaning towards LibreSSL. So actually there's another reason why I shouldn't write this from scratch. Encryption is really hard to do correctly and safely, so I'd rather leverage something that's proven. So that's where I'm going to start to deviate from writing everything from scratch. But yeah, so far so good. Okay, I'm going to instrument some more stuff here because I don't know what this processor thread is up to. Let's just, you know what I'm going to do? I'm just going to say, I'm just going to instrument this to death. Processor woke up, and let's say processor is trying to read. We're going to see a lot of diagnostic messages when I do this though. Processor trying to write. And we're already printing something there. Let's print something here. Processor wrote something. And is that good for now? Getting a lot of, there's prints everywhere else. How about another one for at the end here? No, not the end. The wait here. Processor going to sleep. Okay, let's see what's going on. Ooh, it's waking up a lot, but not doing anything. In fact, it woke up so frequently it... Oh no, it didn't exhaust my buffer. Let's see. I don't see where it's writing, though. You're going at this professionally, efficiently? Yeah, well, I say 20 plus years, but I don't know. A lot of that was before modern C++, so obviously I've had to unlearn a lot of old C++ habits and learn the new ones, right? So I kind of should break that up. I have, let's say I have 16 years old C++ experience and like 5 years modern C++. Okay, actually, it does a lot of writing. Okay, where was it told to close? Okay, am I just confusing myself? That should have resulted in something that I'm not seeing. Maybe it was this. No, that's from the test. What should I expect to see? I should have gotten... Oh, I am getting that. Connection with blank closed by peer. Okay, so it's going to set peer closed to true. It's going to call a broken delegate, which it is. And then what do I expect? After it's done writing, it should have gone into here, right? Platform closing. Oh, wait a minute. This closing is not being set. Where is that set? That is set when we tell it to close. Is that the problem? Am I forgetting to tell it to close? I think that's it. We're never telling it to close, so it's just sitting there. But it shouldn't be waking up like it is at the very end. Unless, Yeah, that's it. Where is that processor thread? Let's see. Wait. Yeah, this waking up constantly shouldn't happen. Need to find out why that's happening. Oh, message received. Yeah, that's the test. I think I know what it is, so... We really should... Oh, we already have a condition here. Let me see if that's not happening. Okay, processor wrote something. And then we'll have an additional one. Processor done writing. Let's print that out. Totally understand 0% of server architecture? Well, I'm glad this is interesting. It's a little tougher for me when I can't figure things out, because I start to worry that people get confused and uninterested with me hitting my head against the wall figuring things out. But if you think it's still interesting, I'm happy. Okay, yeah, it's still waking up a lot. That's not good. Okay, that's the previous test. Hold on, this done... Okay, that done writing shouldn't be happening. Oh, it's not that it's done writing. It has... Wrote something, has more to write. Where is wait true set? Oh. It's never... It's only set here. It's... Oh, I see the problem. If the peer end is closed... We should tell it that it, by default, should wait. That's what it is. See, now I'm actually glad I instrumented this, because I got to see more of what's going on. Processor should be taking a good little nap. It should be. I don't want it to wake up. It's very inefficient CPU-wise to be waking up so much. Okay, there we go. Back to the one problem ago, which is that my test is not closing its end. Where is it? We send the message. We get back a close, but we never close ourselves. So the processor is doing what it's supposed to do. It's like, well, you might want to send more. What we want to do is say, close the client end of the connection. So that's client close. At that point, we can say, yeah, it doesn't matter. Let's say true. Close cleanly, right? Actually, I think that is important. If we said false, it would break immediately, and the server end would not receive the data. Okay, we got through, but we failed the test. Actually, that looks like it might be a broken test. Bytes received. Okay, what did it actually receive? 0. Oh, that's a true, right? Broken test. Hey there, multiple pixels. I've seen you before. How are you doing? Look, I passed my test. You're just in time to see... What was that? The last half an hour of work? Finally come to a conclusion, and I'm done testing. At least that case. So... The reason why, if you're just joining, the reason why I'm doing all these prints now is there's some problem with my computer with Microsoft's debugger. It completely blue screens my computer in the debugger at times. So I'm trying to avoid actually running the debugger. So I'm doing more traditional old school debugging, which is print statements, which actually helped me see another bug here where I forgot to tell the processor thread to wait by default if we're just writing. Yeah. Yeah, and it's really hard to debug, right? I've done Google searches. No one else has blue screens that I know of. when they're just debugging in Visual Studio. It's just me. I'm still thinking it's a hardware issue or I need to reinstall Windows. Either way, those are tough problems I don't want to work on stream. I don't think I could actually do that. I'd have to have a second computer, right? Yeah, the blue screen though, what's really scary is that should only happen if there's a kernel panic, a bad driver, or a hardware issue. All of which scares me because those are hard problems for me to figure out. I'd much rather it crash because of something I did rather than something that Microsoft did or something that's wrong with my computer setup. And let's see, we can now remove all of those prints, right? Yeah, so this is pretty chatty. We'll first start removing those. Now I'm pausing to think, do I want to keep them for future work? I have this concept of a level with the diagnostic message, so I could make level 0 like completely over the top debugging and then just raise the minimum to 1 for everybody else. Having an interview with Naughty Dog. Need to refresh your multi-threading knowledge. Oh, I never said hi either, did I? How do you say your name? Koba? Hello, Koba. Good luck on your interview on Monday. If you have any questions, by the way, feel free to post them. I am doing some multi-threading stuff in here, like this. Colby. Okay. Yes, if you have any questions about multi-threading, I don't claim to be a guru, but I can tell you what I know. For example, this is my favorite way to form a critical section so that the processor thread is not racing some other thread that's maybe telling us to stop or putting data in our output queue and all that. I use a unique lock so that I can do a wait. Where's the wait? Right, well, basically right here. This I have to do kind of crudely because I'm using a Windows OS wait. What I'd really like to do is have a condition variable. Always use lockguard REI for your min-texes. Yeah. I would use lockguard. I have to use unique lock because there are sections here where I need to. You don't want to hold a lock while you're doing a wait. That's really bad. So normally I would use condition variable, which does also require unique lock because condition variable, I'll probably have an example of that here somewhere. Yeah, like one of these, right? It takes the lock as the first argument. It needs to be a unique lock because what it does is it atomically releases the lock and starts waiting for this to be true, basically. And then grabs the lock again when it's done. I really like this because it's very compact and it says, I'm willing to wait on this condition to be true up to this amount of time and use this lock to synchronize. So shared pointers are not thread safe? I thought they were. I thought I read somewhere that they are atomic. How do we look that up? In the manual, I guess? Let me find my manual. I thought shared pointers were thread safe. Let's look it up. I can't make this font. I don't know how to make this font bigger, so I apologize. I thought they said it's atomic. Oh, you're right. Okay, so multiple threads of execution access the same shared pointer without synchronization. Any of these accesses uses a non-const member of shared pointer. Then a data race will occur. Shared pointer overloads of atomic functions can be used to prevent the data race. So what are those overloads? Okay. Yeah, they're basically the standard set of atomics. Exchange strong, etc. Okay, good to know. I didn't realize that. Okay, so everybody remember, standard shared pointers are not thread safe. Let's make a note about that, because I am actually surprised I learned something. So Today I learned shared pointer is not thread safe. I thought it was basically... I thought its members basically performed atomic operations, but they don't. Makes your brain hurt. Yeah, well, it's not for everybody. I will be doing occasional React or JavaScript stuff, so it won't all be C++. Let me, I was going to go remove some of this extra stuff. Yeah, we don't, or was I was maybe going to keep it in, but increase the level? Increase the minimum level, so that would be where? I think that would be up here. Not up, down. Down, down, down. Yeah, getting close. Here it is. Minimum level, it's kind of hiding out there. If I set that to a 1, it becomes much less chatty, I think. Yeah. So now it's just the test printing out its stuff, which we can remove. I'll just look for my printfs and just remove these ones. I'll keep in the rest. Cool, so let's run all the tests to make sure nothing's broken. Have I heard about Jai? No, I haven't. What's Jai? Should I Google search that? Jai. Am I going to get in trouble for searching for this? Okay. It's an overloaded term. Which Jai are we talking about? Not that? Jai. Am I going to get in trouble? Let me do this off screen. Oh, it's this thing. High level programming language. Okay. Huh. A new programming language that is old. There are a lot of programming languages out there. Oh, they even mentioned brainfuck. Oops, I said the F word. Oh well. This reminds me of D. Do you know D? It's supposed to be like C++ the way it should have been written. Let me maybe bookmark this in the notes. This is interesting. So read about this interesting language. Thank you for that. Data oriented. Okay. Cool. Very interesting. Yeah, I like the demo videos. I'm a visual learner. If there's a video, I learn a lot more than reading. Second place would be, if there's no videos, I like it if they have tutorials I can walk through. Alright. I ran all my unit tests, right? Ooh, I broke some stuff. Awesome. Seg fault? Say it's not so. Why am I getting a seg fault? In sending message. Thrown in the fixtures destructor. Links should not be banned. Go ahead and post. Are you getting like a band or something? Cool. If you don't mind, let me just bookmark that for later. That's related, I'm guessing. Yeah, you won't get timed out. I'm a nobody streamer, right? I don't have anything set. I think I only have the minimum naughty words filter on. That's about it. Okay. Cool. I'll watch that later. Thank you for that. This sending message is crashing in the destructor. I think I might know why. Our destructor's tearing down client. We might be using Delegate that, yeah, so actually I'm not sure. Should I risk the Kraken and run this in the debugger? Risking the Kraken whenever I do this. But when it's like an exception, I want to see what the exception is. I might risk it. That's debug windows, exception settings, turn on C++ exceptions. Okay, here goes nothing. All right, we didn't crash. Didn't crash the system, but we see where the problem is. I think it is in one of my lambdas. Huh. That's interesting. Let's see. Trying to connect causes a connection broken? How so? It's completely trashed. Oh, wait a minute. We're closing it. We're on our way out of the... Oh, I see. Why does it think it's here? Seems it wasn't a very graceful connection. I'll definitely watch them, but if it's okay, I'll watch them later. I'll learn to hate Straustrup. We'll see. I'll let you know. I'll put it... Actually, what I'll do... That's why I have this retrospective thing. If you check back later, I'll probably write down here what I thought of this. So if you come back later and says, I hate Straustrup, then you know you were right. Let's see. I'm wondering why the stack thinks I'm here. Oh, I think our delegate is busted. Yeah. Why are we closing immediately? The socket is invalid. It wasn't at first, but then I think I know what happened. It went and it closed it, and then it actually printed that. Yeah, I think our delegate's busted, so that... Where is it? I guess I can't see what test that was in. That was in sending message. We registered a broken delegate that was destroyed before the socket was. So let's see where that happens. Where's a broken delegate? Actually, I guess it's this owner thing, right? Yeah, I see what's happening. So it's registering some delegates that need access to these owners. Let's move them to our unit under test. That'll clear things up. I'm gonna do two things actually. Hold on. Don't need both of them. I just need one of them. We'll be extra safe here, so we'll have the client connection owner. Is it always called client connection owner, or is it ever called client? Okay, I call it client owner in a few places. Yeah, see, I'm gonna do the same thing I did here to make it safe. So we'll make it client owner, and we'll make it a shared pointer, just so that its lifetime will last long enough to be used by the delegates we pass to the client. we can go ahead and make it here and say this is used to capture callbacks from the unit under test. Client connection owner, I'll remove that. And everywhere that it exists, actually. Looks like a bunch of tests use that. Okay, now I'm going to go through and rename this to client owner. How come it thinks I'm still debugging? That's kind of eerie. Anyway. I thought when you hit stop, it's supposed to remove the debugging windows. Alright. So yeah, everywhere we're doing this, we do this instead. Or should we do... No, we'll do this. That the test lives at least as long as the thing it's tearing down. Actually, if that's true... No, I don't want the client owner to be destroyed first, so I'm going to keep it a shared pointer. The client will end up holding on to the delegate, so it ends up... actually... Yeah. Hold on, wait a minute. No, it's not true. I don't want to capture this. I want to do this. So auto client owner copy equals client owner. Yes, so I want to do that. That's safest. Client, oh, just search for errors. So here we go again. I want to copy this down to here. This is maybe my my weakest point in using modern C++ is I'm just not careful enough in the lambda functions I make. I end up capturing or using things from the lambda function that have been destroyed. So I'm kind of paying the price for that in weird crashes. So yeah, avoid capturing things by reference, and when you do capture something, you gotta really think to make sure that it's gonna live, the thing that you're capturing is gonna live long enough. Live at least as long as the lambda function itself. Well, what didn't it like here? Oh, that's just delayed. Error appear. Okay, yeah. Okay. Arrow, and then we're gonna make a copy of it here and use it here. Okay, I misspelled it. Okay. Are we done? Let's see. I think so. Let's run our test again. Okay, so we're getting a crash still. And initiate grace, close gracefully. Does share pointer survive inside a lambda capture? It's passed by values, so yes. Basically, when the moment you make the delegate, you're adding a reference, and then when the delegate's destroyed, you release the reference. This test is crashing. It's just crashing, and we don't know why. Oh, it has its own client owner. I need to be careful about that. Yeah, that we don't want. That's probably why. using one on the stack, which is destroyed at the end of the test. Eh. Use the one from the fixture, not our own, right? Okay, any more? Any more? No? Good? No, there's one more. Okay. Hopefully that's it. I'm getting kind of tired working on this network connection stuff. Good. All right, everything is working now. Cross your fingers that the whole suite works. No, I still have problems in HTTP network transport tests, but they're not crashes, they're just failures. Let me check in this so far. This is a bunch of fixes, wasn't it? This is basically adding the concept of graceful versus abnormal abrupt closes. That's basically what we did. And we added a bunch of... Oh, I bet the other test is failing because of the extra diagnostics we're printing. For web servers, are there really any big allocations? Not really. Imagine the memory usage of a web server being too high. If you're not smart and your web server needs to handle millions of connections, you could just have large memory allocations because you're being stupid. And I'm probably stupid in my web server right now. If I was going to use this for like real company stuff, I'd test it with like 1 million connections plus and optimize and remove. You're going to remove inefficient CPU usage, inefficient memory allocations, and of course any bugs that you find. But yeah, I would imagine most of the memory usage of a web server is the connection state. So like if you had 1 million connections, you're going to need to have 1 million at least entries in a list of port numbers and addresses, right? So what else would you have? If it's a, what do you say? My brain is pausing for some reason. I'm having a moment. The kind of web server that it's stateless. How come I can't remember this word? It is stateless web API. REST. If you have a web server that's just stateless, you're using REST APIs. I can imagine the only allocations you'll have are the connections themselves, and nothing else. All your real memory allocations are in your database and stuff like that, right? Okay. Hey there, Ubi. How's it going? I have a broken debugger, by the way. I'm trying to debug today the old way. Print messages. Okay, this is a whole new test. Actually, I had 2 tests. I didn't fill in the second one, did I? Oh, I didn't even copy it yet. So I had initiate, close, receive, close. And I don't have receive, close abruptly yet. Well, we'll just check it in what we have for now. So let me go through just carefully. So redesign network connections, broken delegate, and fix issues. So provide broken delegate with flag indicating whether or not the peer is closing gracefully or abruptly. Yeah, well, I'm ending up using prints now because my debugger hoses my system, so I'm trying to avoid using it. So this is what I added. I added a bunch of these diagnostics send information. And why is it so long? That's just my style. I'm not very good with names, so I just write long names. Okay, so generate lots more diagnostic messages from network connection processor. Wrap that to ensure proper operation. I might remove those diagnostics once it's battle tested. Okay. See, this was a bug here. So fix bug in processor thread, not waiting when peer has closed gracefully and we're just sending data, but there's no data to send. Oh, there's a insect crawling on my monitor. Uh-oh. My wife's not gonna like that. We have insects in our house. Okay. Whoops. Okay, the diff is just getting kind of confused there. And more diagnostics, more diagnostics. Okay. What else? Okay, we changed the behavior here. So send a second broken delegate call when the connection is finally closed at the end of the close handshake during a graceful close. So the idea is that you get two calls to the delegate, one where it's true and the second one where it's false. True being it's a graceful close, and then the final close is abrupt. And then what else did we change? Okay. Network connection tests now prints out diagnostic messages. Okay, can now print out diagnostic messages from the unit under test. And those are just incidental changes from the others. So push that. Let's see what else I might have changed. Okay, we're good. Let's fill in this test though. Not this one. Copy of this one. Come on. Visual Studio, please. There we go. It's going to be receive close abruptly. And then unoutline. Okay. Sure, let's see them. We don't need to see them in this last test though, because we're done looking at them. Where was it? We'll see these ones for now though. Long tests, huh? Okay. Set up a connection. I know it's set up a server to receive a connection. Have the unit under test connect to that server. Then start sending a message from the client to the server. Right, so we're issuing an abrupt close from the client. Correct? How come I'm not seeing what function I'm in? Oh, it's receive a close, so it's from the server. So to do that, it is not shut down, it's close socket. Oh, and I have this one wrapped previously up here. So on POSIX close socket is just closed, so I can do away with the differences between platforms there. So we'll verify the client receives the abrupt close notification. So that's a false here. And it really doesn't matter what we do from then on, right? Actually, what we'll do, we'll close our end. No, we don't close our end. It's broken. We'll verify the client connection. Actually, we're going to move this. What we'll do is we'll try to receive data, but we'll verify that the client receives the abrupt. Yes. Verify client connection is broken by broken before all of the data is sent. Yes, so we will loop. We will say if bytes received listener equal to 0, then break. And then we will expect less than. So we'll expect that the bytes received is less than, no, it's total bytes received, is less than the data size, yes. Too many parentheses. And if it's not, how come it didn't like that? I don't know. We will print out total bytes received, I guess. Oh, because it's redundant. There we go. Verify client receives the abrupt close notification. Yes. Okay. And then we're done at that point. Let's try that out. So this is... Usually Visual Studio tells me what function I'm in here, but it's not for some reason. Its IntelliSense is broken right now. Receive close. Okay, it's not working. 1225. Oh, that should, yeah, it should be false. This is not receiving a false. Broken gracefully. It got a graceful close? It shouldn't have. Oh, wait a minute. That might be the default behavior of this. I need to look that up. I think in Windows, like, it tries to be nice. So how do we actually close it abruptly? Okay. Maybe it's this linger thing. Here's what we want. So we want... And where does it say that the default is? I guess we want to set sock opt. Okay, so this is going to be ugly. Maybe we only have to do this in Windows. Yeah, this thing. Actually, it's before that, right? So I don't know what to do here. Figure out what, if anything, we need to do to ensure that closing the socket is immediate. Abrupt, abortive. No, I don't want to use abortive. Abrupt or... yeah, abrupt. I don't remember what the other word I used was. So, in Windows it says I gotta call set sock opt on the socket. Level, okay. The opt name is don't linger, so I don't know what level is. Opt name, so don't linger. Hate that you don't understand and know the details of OS differences. Yeah, there's some study and research you have to do, so I mean, I've done socket work on Windows and POSIX before, but I still don't remember all these details. Part of me thinks that if I implement it here in this network connection class and then close that up, I never have to look at it again. Okay. The options value is going to be it's going to be a linger. Some kind of linger class. And then size of linger. And then we probably won't care about what the return value is. Let's see what this sock opt says. Okay, I guess it's SOL socket. And then I guess it depends on the yeah, so they list it here. SO don't linger. Oh, bool. Oh, maybe we want linger with, so we can set the whole structure. So it's just linger. I like these types. Not. What's linger have in it? Struct linger, okay. Okay, so it's just on, off, and linger. Okay, so what does it want? Const char, okay, fine. Does it really want a const char? It does. Okay, whatever. Strange. We want hard, so we want non-zero on-off. How about a 1? Okay. And then 0 for linger. There we go. That's what I want. Let's do this. There we go. I'm hoping that in POSIX, it's just when you close, it's a hard close, and I don't have to do this crap in POSIX, but we'll find out when I run it on Linux. Okay. Yeah, I think the reason why they do this, they make you do this, is if you don't do this and you wanted a clean close, and a lot of people just close the socket and they don't do a shutdown first. They don't do the whole dance that I do in my classes processor thread. Then the end of the connection date is lost, and so they introduced this concept of lingering, where you can close the socket and it's like not really closed for a few seconds. It's lingering, and they said, well, we'll just make the default to do the lingering. In other words, it's sort of a quasi-graceful close, where the program has already told the socket to close, but the OS keeps it open for a little bit longer. And this is telling the OS, no, we're hardcore, we'll take care of it, don't linger. Personally, I think it should be the other way around. This lingering concept, I think, should be something you opt into, but I guess Microsoft wants you to opt out. I'm hoping POSIX, like in Linux and Mac, it's the opt-in thing, and I don't need to do anything. So we just changed system abstractions, correct? Yeah, okay. So let's check that in. So we added... Okay, we removed that. Let me stage that. Yeah, so network connection tests. Don't need diagnostics from receive. Well, let's just keep it short. Turn off diagnostics. And this actually never needed to see diagnostics. I figured it out without it, so we'll just remove it. And that can just stage this whole test. network connection tests. Test receiving an abrupt close. All right. Cool. Let's run all. Let's run on the dangerous side and run our whole suite. Oh no, we're seeing that. Oh, I think that's because of extra diagnostics, but we'll see. We'll run it manually here. HTTP network transport test debug. Yeah, so it's getting all this extra diagnostic stuff. So that's easy to fix. We go to HTTP network transport tests here. And I think it's like a lone 0. Here it is. Actually, it's not this level, it's in the transport itself. Actually, it's where we subscribe in here, I think. Going to watch some games? Okay, have fun. There's a tournament going on? Cool. See you later. Let's see. I'm hooking up. I think it's when we wire up our adapter, right? No? At some point I connect the diagnostics. Where do we do that? Is that here? No. I think it's here. Yeah, so we're not setting a minimum level. Let's set a minimum level to 1. I think I might need to adjust some of my other diagnostics. Because now we'll probably be under diagnosticing. Yeah, see, we're going under. So let's raise the diagnostics a little bit in network connection. Send diagnostic. Error, 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 error. Warning, error, error. Okay, those are the verbose ones. We keep those at 0. This one bump to a 1. Verbose, verbose. That goes up to a 1. That goes to a 1. Why am I doing both? I don't know. Okay, that was it. So we'll need to make sure that the message level is correct in the test, though. Well, actually, running the test, it'll tell us. Yep, so 437. Wrong file. There's a 1. Actually, there's a 1 there too. Okay, yeah, that was kids coming home. All right, let's run all the tests. And the chat room probably is not... the chat room is probably sensitive to the diagnostics as well. That's web server chat room plugin debug, chat room plugin tests, right? Oh, wow, there it passed. So maybe there's some kind of race. Let's run that a few times. I don't think this is related to the diagnostics, actually. If I can't get it to happen, I'll just note. I'll note that it's there. And then try to capture it later. Okay, it's not happening. So let me make a note. And the to-do for... oh, we don't have one here. Chat room plugin. Track down transient test failure. So we'll look for that later. Cool, our tests are passing. I'm gonna need to take a couple minute break to refill my tea, so should be under 3 minutes, but let me check in my code first. This was, right, raise network connection, raise non-verbose diagnostics level from 0 to 1. Okay. Network connection diagnostics raised from 0 to 1. Ignore level 0 diagnostics from network connection. Expect level 1 diagnostics. The diagnostics levels are pretty arbitrary. The only ones I have sort of assigned a value to are warning and error. And I did that in this class here. Mostly because I wanted to keep it loose and flexible. So the de facto standard now, at least in this network connection class, is level 1 for debug level but not verbose, and then 0 for these verbose ones. I'll probably stick to that standard. Okay, I'm gonna go refill my tea, so I'll be back in a couple minutes. Be right back. Hello, I am back. So, I think we're done with at least one thing here. Don't say Okay, we did that. And we did that actually at the same time, almost. Okay, that, I'm not sure if we did. So I'm going to look at this connection adapter. I think it might still be doing the wrong thing, so we'll need to have a test for that, if so. Actually, we should have a test for it regardless. That was break. Yeah, so we don't have a test here. It's not doing the right thing. So let's make a test. I was hesitating from making one yesterday because I wasn't in the right mood, I guess, to handle that kind of a test, but let's try to do it now. This client broken might actually be kind of what we want. Okay, so that's if we close from the peer side. And this is the, so we basically don't have a test at all for that. And also this is only testing one kind of close, isn't it? Hmm. Is that really what we print? We don't print that it was like abruptly broken. Oh, that's interesting. Oh, because that's sent by the underlying layer here. Oh, I think I know why. This close, I think we're running into the same thing that my test was just doing, that linger thing. I think it's not doing what I expect it to be doing. Our network connection actually isn't doing this either. We should do this. And that means probably one of our tests is broken because it's not, the send abrupt should actually do the correct thing, shouldn't it? So it's one of these. I'm just collapsing them as I go through. Initiate close abruptly, I think, is not right. How are we going to test it, though? Actually, what I think it is we should expect that it never to be equal to 0. A good unit test would be to botnet your refrigerator, and then just ping the server. Or like to bring me a beer. Good unit test. Refrigerator, bring me a beer. You'd be surprised, like, if you're unit testing hardware, you might actually want to do that, right? I have a wacky sense of humor, by the way, so if I don't understand the joke, or if I laugh when it's not a joke, it's not your fault, it's mine. Let's see. Yeah, what my understanding is if receive returns 0, it's an indication of a graceful close, so we don't want to see that. We want to expect false that bytes received equals 0. It should be abrupt closes, you get a negative number, I believe. Let's see that. So I think this will fail our test. System abstractions. This happens. I wish the IntelliSense would tell me. Initiate close abruptly. Yeah. So I think the way to solve this is we just do this linger thing. And we can do that at any point after we open the socket, I think. Socket. So we can like do it here. This is Windows only, so I don't need to if-def it. I would just do platform sock here. I think that's all we need to do. That should fix it. Might break other things though, I don't know. Let's see if it broke other things. Okay, we did break something. Initiate close gracefully. There was an exception. And receive close gracefully. Infinite loops. I thought we fixed exceptions thrown from the destructor, but I guess not. Okay. Initiate. Close gracefully. So if it's throwing an exception in the destructor, I think maybe one of my captures is not good. Okay, that's fine. Wait a minute, why do I have 2 of them? Oh, yeah, one from the server, one from the server connection, right, okay. Okay, this is just to do that asynchronously, so that should be fine. Right, there's a shared pointer. Okay, I don't know why that's crashing. Let's tempt fate, shall we? Run the debugger. Initiate, close gracefully. Cross your fingers. Okay. Oh, it's diagnostic messages. Okay. Stop debugging. I think I know where that happens. So that would be in the test framework here. Test fixture, I mean. Where is it? Where is it? Here it is. So it captures this. Actually, I'm not sure why it would crash. But we really should unsubscribe, shouldn't we? So let's call the Diagnostics unsubscribe delegate and tear down and hope that that clears it up. Okay, good. I don't know why this would cause a crash, because the fixture should live longer than the client. Yeah, I'm not sure why this would be a problem. Oh, maybe because we're pushing back into diagnostic messages, and that's maybe destroyed. That might be why. So if it's destroying bottom up, let's say, it'll destroy this vector, then it'll destroy client, and during the client's destructor, it's going to close the connection, which generates a diagnostic message, and then it goes into our delegate, and that tries to push back into a destroyed vector. I'm going to guess that that's why it was crashing. So just a side note, kids who ask at lunchtime, can I have Cheerios? The answer is always, eat something with a actual protein in it first. Then if you're still hungry, you can have Cheerios. Alrighty. So let me run the whole suite. All we did was change the linger option. Yeah, so we're failing network transport tests. I kind of expected that. I think that might just be the wrong messages expected in that test. Or actually, hold on, let me look. That might be because the class itself is not doing the right thing, which would be great. Line 437. So we're expecting closed pipe here, and instead we're getting closed connection. And client is network connection, okay. Let me just look and see, when is that sent? Ah, yeah, so we're expecting the wrong message. We should get this one. closed connection with. Actually, I wonder if we should print something else like closed by or broken by peer. I think I do want that, so we have a closed by peer. Let's print one here. Actually, we'll replace this one. We'll say broken. Actually, I'm going to revise that. Just to keep it consistent, we'll say closed abruptly, and this will say closed gracefully. And then wherever we expect closed by peer, let's update it. So here, what are we doing here? I think it's abruptly. Oh, wait a minute. No, this is from the WebSocket. Okay, never mind. This one is client broken, and it's abrupt. Okay, I think that's what I want. And we have tests to make sure that those diagnostic messages are correct, but I don't think I'm actually looking at them. Yeah, so let's put in some code to look at it. It's this kind of a thing I want. So receive close abruptly. Let's just put it at the end. And actually, I'm not sure what it looks like. Let's make it... This will definitely fail. Let's just see what I actually get. Network connection 1, okay, yeah. Connection width. Closed abrupt. Yeah, that's what I expected. And is that the only message I get? No, I get a second one. Connection, a closed connection with. It's closed connection with. And of course, I'm gonna have to turn those into formatted strings, aren't I? And I need to know the string. Let's see if I do that anywhere else. I do. Aha. Okay, I need int types for that. And I need the port. Port is what? The bound port of the server side. Oh, it's server port. Okay. Did I get this right? I think I might have gotten it wrong. It's the client side ID, the client port, right? No. It's the client generating the messages, so it'll be the server side, yes. Oh, but it's not the server port, it's the server connections port. Where do I store that? I don't. Huh. Well, it'll be whatever. It'll be client-bound port, won't it? Const auto client port equals... No, it's not client port. It'll be server connection port. It'll be client.get peer port. I think that's what we want. Yeah, let's try that. All right, let's see. See if I got it right. Got it right, okay. So let's do the same kind of thing for the graceful close. Receive close gracefully. So down here, and where is that connection after it's been connected? Right there. So we'll say gracefully. That's what we expect. Let's see if I got it right. I did not get it right. Oh, there were just additional messages. There's a closing and then a closed. Actually, that is expected, right? If it's graceful, then after we're done, it'll be closing and then a closed finally. Cool. I like it. Let's check it in. Yes, exactly. What we are doing is network connection. Fix issue in close, in abrupt close on Windows, really. Set SO linger option on socket so that we can actually close abruptly if we want to. And then enhance tests, unit tests, to verify that closes are actually graceful or abrupt as expected. I'll need to test this on Linux and Mac to make sure I did it right there. I'm just assuming that on POSIX, like Linux or Mac, the default is for there not to be this linger thing, but I'm just not sure. Okay, we still gotta go fix that problem with HTTP network transport. Okay. Oh, it's actually doing it correctly now, only we're getting an extra message. I'm right here. Oh. So it's actually closing before we call break. I suppose that's normal, right? It should just close immediately. Yeah, so we shouldn't have to do that, because an abrupt close is a reset. So let's do that and then just combine these two like that. Cool. So that's client broken abruptly. Now let's make another test where it's gracefully done. Client broken gracefully. So the same setup, only we'll close gracefully, or cleanly actually, is another word I use sometimes. Clean or graceful, okay. So here we should get gracefully. And actually, I should have made a copy before I changed it, but we need to put the close back in there, right? So we're not going to expect it to be closed yet. We'll clear the diagnostic messages. And I forgot how this works. It's client is the unit under test, correct? No, it's not. Client is not the thing we're testing. We're testing the transport, so it will be this connections, right? Connection 0. Let's cheat and look at the go to that component and see what the changes are so far, because it's the code I used to have in there. Yeah, connection 0 break. It doesn't matter what we send. I actually don't care. It will be that it closes it. Let's try that out. Huh. 497. Interesting. We didn't get the close callback. I didn't think that this would... Okay, maybe it's just because the code is not set up to handle graceful closes. It'll be in this code here. No, it should have called the broken delegate. Ah, okay. Not setting it for some reason. Let's turn on printing diagnostic messages, shall we? Oh, I don't have that in here. Let's add it in here. Print diagnostic messages. And then if that's true, we do an extra printf. And then we'll set it in that test we're having trouble with. Broken gracefully. Let's try it out. Huh. And it's probably not... Yeah. It's not printing out all the diagnostics, so let me look and see. Actually, you know what? The test failed before we even got the diagnostic message, so there's something wrong with this close, I think. So close, it's going to do graceful. What does it do for graceful? Platform closing. It should send a shutdown. I need to see all these diagnostics back, I think. That's the one problem I'm having. Yeah, let's see some client-side diagnostics. So we'll just kind of copy this stuff here. down to here. Where's the client? Where are you? There you are. We'll call this client diagnostics. This is client now. I don't do this, I'll just print it. And I don't need to capture this actually, which means I don't need to unsubscribe from anything, so it should be good. Just see what's going on. Huh. Client broken gracefully. It actually closed it and there was a second pause. And then woke up trying to re-closing and done sending. Told to stop. Close gracefully by peer. How come it's printing down here though? I don't understand because when we call close here, we should get this with graceful true. So we should get that call. Which is up here. Should set broken to true and notify our condition, which is what we're waiting for. Okay, I'm going to turn on a little bit more diagnostics at this level. We had it tuned down, right? Subscribe, here it is. Turn that back to 0. Run this again. Okay. Huh. Let me see if I understand this right. Okay, so that's the client close graceful. It never woke up though. It woke up a second later. What happens if I extend that wait? What is it actually doing? I just feel like there's something I'm not understanding here. Dare I run it in the debugger? I guess so. What I want to do is hit break and see what's going on. So, yeah. Client broken gracefully in this test. Client broken gracefully. And then tell it to go. And then pause. So that's still waiting. What is broken set to though? It's false, okay. Look at what this thread's doing. Whoops. I'm not sure which one that is. Okay, both sides of the connection are asleep. Why are there 3 connections though? Oh, one of them is a server? No, that's not right. Why do I have 3 connections? See what's going on. What's going on? Okay, the client socket is 132. Oh, hold on. I think I might know what it is. I have an idea what it is. This sets the closing flag, right? But it doesn't call shutdown until it gets to this point. And there's no bytes to send. But it's still sleeping. Nothing woke it up. We need to have this processor state change event signaled if we close, I think. Yeah, we need to do this thing basically if we close down here. I think that's what it is. Because it might be sleeping. So we need to do this. Basically to wake it up. And we didn't see this before because we were always queuing a large message before calling close when we were testing. I believe that's what's going on. I know, I got different behavior now. Oh, because of all the extra diagnostics. Let's turn those back off again. Okay. That would be here. 1. Okay, cool. That's what it was. Let's see. Should I have a test for that? I should, shouldn't I? Let's make one. So turn off the extra diagnostics that we had on here. It's probably, yeah, there's another set too, right? So this set. Where did I do that? Right here. Cool, so these tests should be working again. Cool, let's just check that in. Diagnostics. Okay, we'll leave that in. Abrupt, graceful. Although, you know, it shouldn't be passing it because I didn't actually fix the code. It's this break, right? It's not doing the right thing. Why is it not doing the right thing? Oh, that's because I never did the test. Hold on. I made client broken gracefully, but I didn't make the other one. Oh, I did make the other one. What's going on? Oh, I screwed up. This should be a... No. It's the other direction, right? Yeah, I haven't written tests for it yet. We'll just check this in and say this... What is this doing again? This updated the test to expect the correct diagnostics back. Okay, that's what we'll say. And we added one for client broken gracefully. Okay. So there's no problem gracefully closing the connection from the client end. It's the server end that's probably still broken. Okay, so update expected diagnostics and test client side graceful close. We'll check that in. I'm actually going to run out of time. So I'm only expecting to stream until 3, but let's see how far I can get. We'll make a test that should pass right away, which is server broken abruptly. So what do we expect here? Instead of closing, here's where it differs. So instead of closing the client side, we close the server side. Where do we do that? Here? Here. And we close it abruptly. What do we expect to see? The client broken. Okay, I'm not doing anything there. Okay, so we need to do that. So I'll move this stuff to here. And let's add some information here. Broken gracefully equals graceful. Capture it. And then we'll pass it in here. Then we can just do the same kind of weight here. So we should expect it to be broken, and then expect it to be not graceful. And then what diagnostics do we expect? Not abruptly, but closing, right? Connection with, and then a closed, I think, but let's see. And didn't compile. What'd I do? Oh. I suppose we don't care about this anymore. Oh no, we still need that. What am I doing? We don't need the broken delegate though. And, oh, I guess I still need those conditions. We're sharing it with the other waiter. Yeah. All right. Okay, it's just closed connection with, right, because it's abrupt. Okay, let's do that. Closed connection with. I saw something else there, but an error in selecting the events. I'm not sure where that's coming from. Is that because we're closing too quickly? It might be. Yeah, I think this break is racing a processor thread, so... How do we avoid a race? I suppose we could send something and wait for it to be sent? So, something like... Let me think about this. Actually, what it is we're this notify wakes up this wait and it's too quick. I think we're not wiring up the adapter quickly enough. Actually, no, that's not true. Although that is a problem. We should wire it up and then call the new connection delegate, shouldn't we? It still might race though, because this process starts a thread, and if that thread doesn't... Oh, wait a minute, no, the event select is done in the process, so that probably fixed the race already. Okay, so it's just a different error. Huh. The test broke that shouldn't have broken. 370... Whoa. 375. Huh. It didn't send the message? Client connect. Client process. Send his message. Oh, is this the change I just made broke something? Data received should not raise connection delegate. Oh yeah, that's why we did this first. This is so that when we wire up the adaptee and we receive data right away, it doesn't get lost. Okay, so there's just a problem here in our test. So return back to where we were just a second ago. $600. I should make a note in here. Note. Note. It's important to announce the new connection first before wiring up the adaptee, so that the new connection delegate has the opportunity to register its delegates, right? And that's through set data received delegate, set broken delegate. It's delegates. Before the adaptee tries to call them. Before the adapter tries to call them. Before the adapter receives callbacks from the adaptee. Otherwise, data or callbacks may be lost if they happen before the new connection delegate registers to receive them. It's just that we have the other problem that how do I explain it? That if we break the connection, if the new connection delegate then goes and immediately turns around and tries to break the connection, if that happens too soon, then when we're wiring up the adaptee, it will the socket will already be closed. Actually, we should allow that, I think. Shouldn't we? Let me think about that. No, well, hold on. If it's because it's an abrupt close, right? that will close the socket right away. This close immediately sets the socket to be invalid, so we don't even... Yeah, I guess we don't want to allow that. So our test is... Well, hold on. Let me think about this. There's sort of a race. Because we tell our new connection delegate, hey, there's this new connection, right? And then, but until we wire it up, they might try to use that connection, like to close it. And then we really have no way of telling the new connection delegate when it's ready. So I wonder if we can reverse, if we can swap these two and yet have the wire up. What would the wire up do? I have an idea. I know what we'll do. So we will allow new connection delegate to actually return another delegate, and we'll call it. So here's what we'll do. Const auto ready delegate equals that. And then we will call it if it's not null. So this thing, whoop, this thing, it's going to be a little bit more complicated, isn't it? So let's turn it around. Let's have a reverse direction delegate. So connection ready delegate, and we don't need any state, so we can actually make this a bit simpler. We'll say this is a certificate delegate. The user may provide, in order to be told when a connection is fully wired up and ready to be used by the user. And there's no other context, and we'll just have it return that. A delegate that the transport layer should call when the connection is ready to be used is returned. Or I'll say an optional. We'll allow null pointer to be returned. Val null pointer. Hold on. This is returned if the user doesn't care to be told when the connection is ready to be used. They really should return something. We'll be graceful about it. So this is a design change. It's going to break a bunch of stuff. I will just go through and check. Okay, yes, so when we get a new connection, I mean, think about this. This is the web server. When the transport layer says that there's a new client, it's going to call new connection. Let's delegate it to new connection to return something. So new connection needs to return this new connection. This connection ready delegate, which is part of server transport. A delegate to be called when the connection is ready to be used is returned. So we set up our callbacks. So we don't actually use the connection other than to set its delegates, correct? So It's probably just safe to return null pointer, actually. Because the server is pretty much passive. It's basically going to wait to receive a callback, and it won't receive a callback until the connection's ready. It's really for use by clients that want to send something right away. Yes. Find network takes a new connection delegate, so we've got to return something. So yeah, all of these tests that don't care will just return null. It's the one we were having trouble with that needs to return something. Let's just have it return the default right now, everywhere, until we get to compile. Alright, and then the problem we were having was in server broken abruptly. We don't want to return null pointer, we actually want to return a delegate here. It's going to be, again, capturing these same things. Again, locking this and notifying the condition, but what we'll do is we'll say ready equals true, or connection ready. Bool connection ready. We have to capture that in at both levels. All right. Because what we want to do is after we do, where is it? After we wait for the connection, we need to wait again. Actually, we can just combine the two, right? Connection, not empty, and connection ready. Actually, we can just return, we can wait for connection ready to be true, actually. That's a lot simpler. Connection has to be ready before we can break it, right? Okay. So we got past that checkpoint. Now we're on this one. So we actually get a graceful connect, really? It shouldn't be graceful. Really? I'd like to see that. Okay, let's see that. Client broken gracefully, yes. Server broken abruptly. That's the test we want. Server broken abruptly. Yeah, just making sure that's the test I want. Okay, so I want to see where that happens. So that'll be putting a breakpoint there. Go. It's happening right there, basically. So it did get a graceful break. It shouldn't have. Yeah, because we did break false. Clean is false. All right, close immediately. Okay, they got a little further. It was sending a diagnostic message. So it had just called close socket. Next socket should have had the linger set up to not linger. So I'm kind of confused why. Is it this thread? One of these threads. Yeah. Why did it think it was broken gracefully? I should have got into here. Very strange. Let's put one there and we will stop debugging and go again. I did get a -1. Oh. Okay, it's a blocking call. What's the main thread doing? Yeah, okay, that's expected. The second time, it also received a -1. Wait a minute, why is this happening? Okay, their amount received was 0. Yeah, that's really weird. It is not doing an abrupt close. I wonder if it's because we haven't queued anything to be sent. And the OS is just trying to be smart. Let me test that theory. So it would be more difficult for the test to do that if we tried to send something. Send data. I don't know. How about 10 million X's? That should be hard. It should be hard for it to gracefully close that one. Really? I'm surprised. Oh, hold on. It's probably queued it up. It hasn't started sending yet. Yeah. It's not so easy to... this is not so easy, is it? Is there a way to reset a connection manually in WinZock? It says we should get a connection reset. Thing is, we're not. We're getting receive returning 0. Oh, maybe this is the problem. Oh, it's if it's set to a non-zero. Never mind. Non-zero timeout interval. I guess L linger is a timeout interval. Okay, I got it. Yeah, I wonder if you can tell it shut down and like, whoa, that is the wrong shutdown. Shut down. Huh, that's weird. There's like no way to force it to reset the connection. So yeah, this is obviously broken, but I mean, the thing is, we're telling it to close, right? And the default for close is clean is false. So it should be immediate and stop processor on this. So it will go to this close immediately, which just calls close. And on that sock, we had set the linger to be 0, so it should be a hard close. Oh, hold on. I think I know what the problem is. We're only doing it for a socket that we created with connect. We're not doing it for a socket that we make when we accept a new connection. That is in network endpoint, isn't it? Yeah. Network endpoint, where are you? It's on the accept right here. This client we receive back. Yeah, so we need to do the same thing on the client socket. I bet that's it. It's not lingering there. Let's try that out. That was it. Although that change might have broken other things. Let's see. That would have been in net system abstractions, right? Let's see if I broke something there. I did. Receive close abruptly. We're getting a closed connection with instead of a closed abruptly by peer. So we're not receiving the closed abruptly by peer callback. 1274 of this one. Oh, that shouldn't have changed. How did that get broken? Is that always breaking? Oh, look at that. No, it's just a race. Something's racing. So when it fails the race, we get an extra message. So we're not waiting long enough. We're racing at some point here. Hmm. I wonder if it has to do with us telling it to linger before we, or after we send the message to it. That was a weird bark. Oh, you might be hearing the kids in the background yelling. Apologies for that. Hmm. want to find this soon because over time. Actually, don't we expect that? Okay, so the problem is we're not getting that sometimes. Where does that happen? That's if we get that. Okay, I'm not sure. Because we do... Okay. So this is never failing. So we're always not receiving all... Well, let's see what we actually receive. Let's see, printf actually received D. Well, it's not D, is it? It's ZU. I'm just curious, what do we see when it passes and what do we see when it fails? So 0. Okay, it's 0, so it's never receiving anything. What if I put in a little bit of a weight here? Sleep for standard chrono milliseconds 100. Never receives anything. Oh, wait a minute. It's not going to because I closed it. Okay, I'm being dumb. Yeah, this is the abrupt close, right? Yeah, of course. Yeah, this is dumb for me to be doing this. This is only for graceful. We can't use the socket. Yeah, okay. I'm just being dumb here. This is just dumb to do. It's probably never going to happen right now because I think the race is that we're closing too quickly. I think we're not waiting until the processor thread is even started up yet. Actually, it shouldn't matter, you know. This is synchronous, so it will, the client socket will be set up. I wonder if it's... Oh, I think I might know what it is. I think what's happening is... yeah, I know what it is. So we're only doing this diagnostic message from a socket error in receive, but we're not doing it from send. Yeah, that's it. So it's sometimes hitting the send. So yeah, it's sort of a toss-up which one it will hit first. Yeah, that was it. Okay. And then what about our network transport tests? Okay, good. If this is all working now, I might just wrap up the stream just because I'm going over and I have some chores to do. Although I didn't get through all my plan. Let's see. Yes, it's still important to do that. We added a ready delegate though. So we kind of made it more user-friendly. We took advantage of it here to be able to wait for it. Okay, so let's note that. That's really only thing we had to do was to add that ready in there. Okay, so have user, well, fix race between a new connection starting and being ready. Better do chores. Yes, we will run out of food. Not have enough to cook, so must go get food. Must wash clothes and do dishes. Have the user, or allow the user to provide a delegate that is called once the connection is fully wired up. The user would wait for this callback before trying to use either or any method that basically requires the connection to be wired up. E.g. closing. Well, expecting something that expects to receive, it's not e.g. Something that, oh, let me think about this. The real thing is we were trying to break the connection. And yeah, we weren't. It was just happening too quickly and we weren't receiving the callback. Because we wire it up after, yeah, okay. We're not going to lose any data, are we? Because wire up add calls process, yeah, so again, so the example is breaking the connection and expecting the broken delegate callback. So you'll miss it because it won't have been wired up yet. And then what was that essentially it? Oh, test. It's broken abruptly and we already had one for cleanly. No, I didn't add one yet. Okay. That we should do. We should do that. Server broken gracefully. We need that, right? We'll just make this as the only, whoops. This is the only thing we really did. Oh, actually, that's not true. Test breaking a connection abruptly from the server side. So I'll do a little bit more before I end the stream. I want to do server broken gracefully. So then I'll feel like I have good coverage, server and client, adapter and adaptee. So that'll be a nice segue. Okay, what did I do here? Ah, that was a bug. That was a bug there. And I don't really have a good test for that. I forgot to do that. Yeah, let's quickly do that. I need a bug. I need a test that tests the bug. So first we'll put the bug back in. The bug was not setting that event. So near line 294. So we will... Oh, is that right? Connection 132. Line 298. Right here. So the problem is if we don't send any data and we try to do a graceful close, it doesn't actually do anything. So what I'll do is I'll take the test, initiate close gracefully, and we'll just make a copy of that down here. And we just won't send anything. We'll just do an immediate graceful close. Connect to the server, yes. Now we don't queue up data. We just do that. We don't verify this, because it's nothing to verify. Not yet indicated connections broken. Then we close it. Yes, so that's what we expect. Okay, I see errors, but let me get this set up to go first. Oh, it's because I didn't give it a unique name. Okay, this is no data queued. This is with data queued. I'll just run both. Oh, I've misspelled something. There we go. Okay, that's not triggering the bug. What's the bug is actually what? It gets stuck, right? It gets stuck waiting, so that would be... We don't close our end. But yeah, we have to detect at the server side. Right, so we'll try a receive. How do we do this? Set it to non-blocking and then do a receive that has a timeout. Actually, we, okay. Yeah, the connection, the problem is this server connection is just a raw socket. Right here. And it's the test here I need to check. Verify that the server side detects the graceful close. To detect it, we try to do something. Well, basically, we try to receive and we should get back a 0. But if it's not closed gracefully, it'll block forever, which will ruin which will make our tests hang. So I think the right thing is to make sure it's non-blocking. And how do we do that? Trying to think of what's the easiest way to do this. So receive, we have these called, right? Something like this. And we say guess I can put this here. So right now it's gonna, oh, what if we say not wait all? It's like, don't wait, right? No wait. I think you just don't use a flag, but then it might block. I need to make sure it's non-blocking. Do I do this anywhere? Oh, don't search whole word. I don't. Okay, well, let's just look it up. It'll probably be under set sock opt. Okay, maybe not. Where would it be under this? Okay, I'm just gonna look it up. WinSock, make socket non-blocking. Is it really IOCTL socket? Oh, okay. Where was I? There we go. Okay. IOCTL socket server connection. Command is what? Ah, here we go. FIONBIO. And then a mode. So not equal to 1. And that takes a U long. That's a very weird type. Really? U underscore long? And 1 is non-blocking, it says. Okay, and then what is it on POSIX? Or BSD sockets? Make non-blocking. Blah, 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 get the answer. Okay, that's not what I want. But I could just shortcut to the answer. Create it with non-block. Okay, that's not it. Set, how about just say Linux? It's gonna be the same. Yeah, gotta read the manual, right? Here we go, maybe this is better. And there it is, I remember this now. It's FCNTL. So, we're gonna need FCNTL for POSIX. FCNTL. Okay, we get the flags right. Let's say int flags equals FCNTL server connection. F get flags 0, and then flags. So we add in the non-block, and then set it. Set FL to the flags, right? Okay, phew. There we go. So what we expect will be what exactly? That it will eventually return 0. But until then, what does it say for receive? Receive, there you go. Rrrg. Blah, 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 blah. Okay, so we'll get socket error E would block. So this is another gross thing. We're going to have another gross thing happen here. Actually, we captured this kind of code in here, right? E would block. If bytes received, socket error, get that. If it's would block, then we'll make a constant here. Would block. That's it, actually. Now, what is it in BSD sockets? Or Linux? Receive. Okay. That can actually pass message, don't wait. Okay, so it just returns with E would block. Which, this is what I actually did. So if it's E would block. Like that. Let me verify. I'm going to go back to my VS Code because it's easier for me to see the Linux stuff from here. It's really in POSIX. It's in network connection POSIX. Okay, I have to do this. If it's if it's negative, check error no. So let's do that. If bytes received less than 0 and it's would block, then it's would block. And the problem is we have to do this in a loop. Trying to think of the best way to do this. Eventually, we want it to be bytes received is 0. Until then, okay, so it's while would block, right? So we'll put that outside. We'll assume it's true and then say while would block. I think I know how I want to do this now. So when it gets out, we'll assert, well, actually, it will always get out. What we'll do is, before here, we'll get the current time. I think about how to do this. I guess we can just be really crude at it. Let's just get the current time. Const auto start time. If time null minus start time is greater than 1, or basically assert false. Alright, so let's try this out. So there we go. It failed because it continued to block. So let's put the bug fix back in. All this just to test a one-line bug fix. And that was where I had something commented out, right? Here it is. So commenting out should fix the bug. See, this is maybe the price of TDD, is sometimes it's hard to come up with the test. And still not working. They put the, hold on. This, still not working. Why not? It should have gotten a 0 out. Oh, it never set it to false. That's why. We need to set it to false here. So let me put the bug back in, verify it fails. There we go. And then fix the bug. Should fix the test. Anyway, what I was saying before, it's the price of TDD. Sometimes it's hard to arrange the test to recreate the bug's conditions. So that took me, what, a half an hour to do it? I think it's worth it though, because now if that ever creeps back in, I'll have a test for it. So there's the bug. This was incidental, right? This is just we didn't have a diagnostic message printed everywhere. So add, this is network connection. Add missing diagnostic message. That's causing a transient, this was, I'll write it out, this was causing a transient test failure. Yeah, big hassle. The gain is that I have that test now. The more tests I have, the more rigorously it will test and catch regressions in the future. So it gives me confidence that my code is correct. Okay, yeah, this was tested by this, I believe. Actually, no, there are two different bugs here. This we need to test somewhere else. This is tested by that test. Okay, that I removed because we don't need to do it. Right. Fix bug in closing gracefully when no data is queued. Wake up the processor thread. Always wake up when closing gracefully, so that it doesn't get stuck and never shut down the socket. That was the bug. Now this is where it's not lingering. Where we need to test that actually, I think. We're sort of testing it in HTTP network transport tests, but we're not testing it near the source. Do we have something that's similar? Okay, well, let me get familiar again. What exactly is the bug? All right, it's that the linger was turned on for server-side connections. And yeah, the problem is these tests are all using client mode. What about this test? Yeah. It's not the right direction. Yeah, the unit under test is always a client, isn't it? Yeah. Let me make a note to do this later. So this will be system abstractions, network connection, test server mode, especially make sure server side connections are set not to linger on close. So it's the next best thing. I'll make a note to make a test for this later, and I'll just check it in right now. Sort of breaking TDD a little bit, but I'm getting kind of tired of it today. So, and I'm not perfect. If I was perfect, I would definitely not have a bug in the first place. Next best thing would be that I would have a test first for this. Okay, so make sure server side connections don't linger on close. It's actually network endpoint. Okay, yes. And then push that. Yeah, I'm gonna wrap up soon. I need to go to the store. Ah, yes. Okay, yeah. So this is a design change. So change HTTP connection. No, server transport to expect delegate to be returned from the new connection delegate calls that the server will use to notify the client. It's not server client, it's what the user of the transport will use to notify the user when the connection is ready to be used. So sort of fix race, well, allow races between, what is this class called again? Connection adapter. Wire up and user access to be avoided. Too long. Prevent races between connection adapter, wire up, and user access. There we go. Yeah, there we go. Oh, forgot to stage them. Stage them. We're good, right? Okay. One final check. And I hope I didn't break anything here. Good. Tests are taking quite a long time to run, though. So let me wrap it up, and then we'll probably host Adam if he's still going. Let's see what's my plan for today. So I did handle this pretty well, I think. We now have the ability to distinguish between graceful and abrupt or abnormal connection closing for our network connection class. And this is a bug we fixed. We fixed a couple other bugs incidentally also. I believe, no, we have not fixed this completely yet, have we? I don't have a unit test that captures that completely. So we didn't quite get to this. So really I didn't get very far in my plan today because this took a lot longer than I thought. So probably tomorrow I'll continue this work. We have to make sure that this adapter does the right thing on break. And I want to make sure the web server handles its connections correctly and things don't linger. And then some fix up to the server and then update the client app. And then I hope to have the stuff live so that viewers can play with it while I'm streaming. That's the whole goal. I'm a little bit behind on that. I was hoping to get it done Monday, but now it's Wednesday. But anyway, such is life. That's going to be it for today. And let's go see if Adam's still streaming and we can host him. Sound good? Let's see. Yeah, he's still going. So we'll go host Adam. If you haven't seen Adam 1353 on before, he's working on a game in JavaScript. Been working on it for several years, and today he says nothing can stop the coding train. So we'll go pass the baton off to him. Thanks for watching.